For all of human history, there has been one place no one else could enter. Not kings, not governments, not machines. Your thoughts. Inside your mind lives your fears, your secrets, your imagination, your silent conversations with yourself. Even language cannot fully translate what happens inside the brain. Until now. Because in laboratories across the world, scientists are teaching artificial intelligence to decode human thoughts. Not metaphorically, literally. The age of mind-reading AI has begun. What does mind-reading actually mean? Before fear takes over imagination, let's clarify something important. AI is not reading thoughts like magic. It is not hearing your inner voice directly. What it does is this. It measures patterns of electrical activity in your brain and translates those patterns into meaningful signals. Your brain is not silent. It is an electrical storm. Approximately 86 billion neurons constantly fire tiny electrical impulses. Every thought, every memory, every word you silently say inside your head is encoded in electrical activity. The question scientists have been asking for decades is, can we decode it? And in 2026, the answer is becoming clearer. Yes. There are three primary technologies enabling AI-based mind decoding. EEG, electroencephalography. Sensors placed on the scalp detect electrical signals. Non-invasive, safe, limited resolution, but improving rapidly. fMRI, functional magnetic resonance imaging, measures blood flow changes in the brain. When a region becomes active, it consumes oxygen. fMRI detects that activity. High resolution, but expensive and bulky. Implantable brain-computer interfaces. Tiny electrodes implanted directly into brain tissue. Companies like Neuralink and academic labs are advancing this field. Direct signal access, extremely high precision. Also, ethically complex. But here's the key breakthrough. Hardware alone is not enough. The real revolution is happening in artificial intelligence. How AI learns to read thoughts. AI does not understand your thoughts the way humans do. It detects patterns. Imagine this. A person looks at a cat. Their visual cortex activates in a specific neural pattern. AI records that pattern thousands of times. Then it learns, when this pattern appears, it likely means the person is seeing a cat. Now scale that up. Words, images, concepts, emotions. Large neural networks are trained to correlate brain activity with language models. In 2023, researchers demonstrated that AI could reconstruct rough sentences based on brain scans. In 2025 to 2026, models improved significantly. They could reconstruct images people were viewing, approximate internal speech, predict intended hand movements before execution, decode imagined speech with increasing accuracy. This is not science fiction anymore. It is early-stage science reality. One of the most powerful applications, restoring communication. Millions of people suffer from paralysis, ALS, locked-in syndrome, and severe speech impairments. For them, the mind works, but the body does not respond. In recent trials, AI has enabled paralyzed patients to generate text on a screen by simply thinking words. The system learns their neural speech patterns and converts them into digital output. For the first time, thought becomes text without sound. This is not surveillance. This is liberation. But medicine is just the beginning. Imagine typing without a keyboard, controlling devices without touching them, navigating virtual worlds using thought, direct brain-to-brain communication. Gaming industries are already experimenting. Defense agencies are researching. Tech companies are investing billions. Because whoever controls the interface between brain and machine controls the next computing revolution. Now we arrive at the most important part. If AI can decode thoughts, who owns your mind? Is brain data private? Can governments demand access? Could corporations analyze subconscious preferences? Could marketing become neurological manipulation? The human brain may soon generate data more valuable than your browsing history. This is called cognitive liberty, the right to mental privacy. And it may become the most important human right of the 21st century. Let's be clear. Current AI cannot randomly read your mind from across the room, decode thoughts without training, understand unstructured imagination. Mind decoding systems require calibration, large amounts of personal data, and cooperative subjects. You can't just scan a stranger's thoughts without preparation. But technology evolves, and early limitations rarely remain permanent. The smartphone was once primitive. Now it contains the world. So the real question is not what AI can do today, it is what it could do
look at this
tomorrow.
brain model. All these folds are the gyri?
In the next
grooves are
10
the
to
soul
20
side.
years,
Amazing.
we may see wearable
it's
neural
moving.
headsets,
Look at that. The folds are
brain-controlled
squirming. This is
augmented
incredible.
reality,
My brain is fried.
AI-assisted memory enhancement, neural search engines, emotion-detecting algorithms. Beyond that, direct neural cloud connectivity, human cognition merging with artificial intelligence, the boundary between thought and computation dissolving. There was a time when the ocean was the last frontier, then space. Now, the final frontier may be the human mind. AI is not just learning to understand language, it is learning to interpret neural
Yes, it's
activity.
consistent with the cognitive
The
task.
question
And the
is
parietal
no
shows sensory
longer,
integration. Right,
can
let's map the
machines
connectivity.
read our thoughts? The question is, how will we protect our humanity when they can?
For decades, scientists could measure brain activity. They could see regions light up. They could detect electrical waves, but they could not understand meaning. A brain scan was just color. A waveform was just noise, until artificial intelligence changed the equation. Between 2025 and 2026, something shifted. Not a sudden explosion, but a quiet, powerful leap. AI stopped just observing brain activity. It began decoding it. Before we understand the breakthrough, we must understand the challenge. The brain is not organized like language. It does not store words in neat digital files. Neural signals are noisy, overlapping, highly individual, time-sensitive, non-linear. When you think the word tree, the signal is not stored in a single neuron. It is distributed across thousands. When you imagine a face, visual cortex, memory regions, and emotional centers activate together. So the problem is not reading a signal. It is decoding a multidimensional storm. In 2025, researchers improved transformer-based AI models to align brain signals with large language models. Here's how it worked. Step 1. A participant listens to spoken stories for hours. Step 2. Their brain activity is recorded using high-resolution fMRI. Step 3. The AI trains on paired data, neural signals plus transcript text. The model learns statistical correlations between patterns and language. The breakthrough? The AI could reconstruct sentences that captured the meaning of what the participant heard, even when the wording was different. It did not decode word for word. It decoded intent. This was critical, because thoughts are conceptual before they are linguistic. One of the most dramatic advances in 2026 was decoding imagined speech. Participants were asked to silently imagine speaking. No vocal movement, no whisper, just internal speech. Earlier models struggled with this, but new deep learning architectures combined temporal convolution networks with transformer attention layers. This allowed better timing resolution, improved noise filtering, cross-brain generalization, and higher semantic accuracy.
Hello, how are you today?
In controlled lab settings, AI could predict intended phrases with significantly improved accuracy compared to previous years. Not perfect, but no longer random. The system could differentiate "I am thirsty" from "I am tired." That may sound small, but it represents a massive leap in neural decoding precision. AI reconstructing images based purely on brain scans. When participants viewed images, faces, animals, landscapes, researchers recorded brain activity. Then, diffusion-based generative models were trained to recreate the image from neural activation patterns. The output was not pixel perfect, but remarkably close. If a participant viewed a red car, the AI-generated output often showed a red vehicle-like shape with correct general structure. If they viewed a cat, the reconstruction resembled a cat silhouette. This worked because visual cortex activity preserves spatial and structural patterns, and generative AI learned to translate those patterns into visual approximations. This is where neuroscience met generative modeling. A major bottleneck has always been signal quality. In 2026, improvements included higher density EEG caps, AI-based noise suppression, advanced signal smoothing, real-time filtering, and personalized calibration algorithms. Instead of treating brain data as static signals, AI began modeling neural activity as dynamic sequences, like language, like music. This allowed improved decoding accuracy. Even wearable EEG systems began achieving better real-time responsiveness, not hospital-level precision, but enough for basic thought-controlled typing. Implantable brain-computer interfaces achieved technical refinement in 2025-2026. Improvements included higher channel counts, wireless transmission, reduced tissue inflammation, AI auto-calibration. The key advance? Adaptive machine learning models that adjust to neural drift. Because brain signals change over time, electrodes shift microscopically, neural responses adapt. Older systems required constant retraining. Newer AI models adjust automatically. This significantly improved long-term usability. Previously, mind decoding models were highly individual. Each person required personalized training. In 2026, researchers improved cross-subject modeling. Using large neural datasets, AI began identifying universal neural features shared across brains. This does not eliminate personalization, but it reduces calibration time dramatically, meaning future systems could work faster with less training. This is a crucial scalability breakthrough.
Initiating protein fold analysis.
Earlier
Watch for
research
anomalies.
required
Confirmed.
offline
Aligning the
analysis.
quantum simulation
In
now.
2026, real-time decoding improved significantly. AI systems now process neural signals within milliseconds. This enables live thought-to-text, real-time prosthetic control, dynamic VR interaction. Latency reduction is critical. If thought translation lags by seconds, it becomes unusable. Real-time processing transforms usability. Another key 2026 advancement, combining multiple signal types, EEG plus fMRI, neural signals plus eye tracking, brain data plus muscle microsignals. Multimodal fusion AI models outperform single-source systems because thought is not isolated, it is embodied. This holistic modeling dramatically improved decoding accuracy. Despite progress, we must remain precise.
Current systems require training sessions, cannot read uncooperative minds, struggle with abstract imagination, do not access hidden memories, do not randomly decode strangers. AI decodes patterns it has learned. It does not understand you. It does not access secrets. It statistically predicts meaning based on trained correlations. This distinction matters because fear exceeds reality. What makes 2025 and 2026 different is not one experiment. It's convergence, neuroscience, machine learning, generative AI, high-resolution sensors, cloud-scale computation, all advancing simultaneously. When technologies converge, progress accelerates exponentially. We are no longer in early curiosity stage. We are in early application stage. There was a time when brain scans could only show color maps. Now, they can reconstruct sentences, images, intent. The technical breakthroughs of 2025 and 2026 do not mean AI can read every thought, but they prove something undeniable. The human brain is no longer completely opaque to machines. And as decoding models improve, the boundary between thought and computation will continue to thin. The science is accelerating, the ethics are catching up, and the future is closer than we think.
What if your last private space was no longer private? Not your home, not your phone, not your encrypted messages, your mind. For centuries, human thought has been the final frontier of freedom. Governments could watch our movements, corporations could track our purchases, algorithms could predict our behavior, but no one could see our thoughts. Until now. Brain-computer interfaces, neural decoders, cognitive AI systems, they are no longer science fiction. And with them comes a question more powerful than the technology
You can see the
itself.
circular metrics show a 20%
Who
uplift.
owns
This aligns
your
with our neural
thoughts?
network projections.
Impressive. Let's drill into the
Privacy
sentiment
has
analysis.
always evolved with technology.
Scan complete.
Cameras
Your neural
appeared,
patterns are a
we
match.
adapted.
Excellent.
When
That
the
was
internet
seamless.
arrived, we adjusted. When smartphones began tracking us, we traded data for convenience. But thought is different. Thought is unfiltered, unedited, unpolished. Inside your mind exist doubts you never speak, anger you never express, fears you never admit, ideas you're not ready to share. Brain-reading AI doesn't just analyze behavior, it attempts to decode intention, and that changes everything. Because once intention becomes visible, freedom becomes fragile. Today, surveillance watches what you do. Tomorrow, it may watch what you consider doing. Imagine a workplace requiring neural monitoring to measure productivity, a school tracking attention levels in students, an airport security system scanning for hostile intent, a courtroom requesting neural evidence. It sounds extreme, but so did facial recognition 20 years ago. Technology rarely asks permission, it advances. And institutions adapt around it. The danger isn't malicious AI. The danger is normalized intrusion. When cognitive monitoring becomes standard practice, opting out may no longer feel like an option. Consent used to mean clicking,
Here, the
I
chart
agree.
displays neural activity
But
peaks,
how do you
and the brain
consent
model
to
shows
something
active
you
pathways.
barely
This
understand?
reveals cognitive insights.
Neural data is not like location data. It is not like browsing history. It is raw cognitive information. Patterns of fear, patterns of attraction, patterns of bias, patterns of belief. If companies collect it, can they sell it? If insurers access it, can they adjust premiums based on stress markers? If employers analyze it, can they filter candidates by neural personality compatibility? The moment thought becomes data, data becomes currency, and currency attracts power. Because of these risks, a new idea is emerging: cognitive liberty, the right to mental privacy, the right to mental autonomy, the right
The
to
neural
mental
network is adapting.
integrity.
Confidence metrics are climbing.
Some
What about the
researchers
anomaly in
argue
Sector
that
7?
brain
It's
data
resolved.
should
We
be
proceed.
treated like organs, not property, but protected identity. You can't sell your vote. You can't sell your citizenship. Should you be allowed to sell your neural patterns? Or should they be legally untouchable? We are entering a legal vacuum, and history shows us something important. When technology moves faster than law, power concentrates before protection arrives. Reading thoughts is one thing. Influencing them is another. If AI can detect emotional vulnerability, it can target persuasion with surgical precision. Advertising already influences behavior. Now imagine advertising tailored to your subconscious triggers. Political messaging optimized to your fear patterns. Content delivered when your neural state is most suggestible. This isn't dystopian fantasy. It is the logical extension of behavioral analytics. And if reading thoughts becomes possible, writing into them may not be far behind. There is another risk: access. If neural enhancement becomes available, who gets it? The wealthy? Military programs? Elite corporations? What happens when some minds are augmented and others are not? We could witness the rise of cognitive inequality, enhanced memory, accelerated learning, emotion regulation optimization, not through discipline, through devices. When intelligence becomes upgradeable, human equality becomes negotiable. And yet, we cannot ignore the miracle. Locked-in patients speaking again, paralyzed individuals typing with thought, depression detected before collapse, PTSD mapped and treated precisely. For millions, neural AI is not surveillance, it is liberation. And this is the paradox. The same technology that frees can also control. The same system
Initiate
that
neural
restores speech
Sync confirmed.
can
Streams are
extract
active.
Overlay the
silence.
projections now.
The
Overlay
question
complete.
is not whether we build it. The question is who governs it. Some countries are already drafting neural data protections. Ethics boards debate consent frameworks. Neuroscientists call for neuro rights. Legal scholars warn of cognitive exploitation. But regulation lags behind innovation. AI systems evolve monthly, legislation moves yearly, and global coordination is fragile. If one nation restricts neural surveillance, another may commercialize it. In a competitive world, restraint becomes difficult, especially when advantage is measured in intelligence. There is a line humanity has never crossed. The line between observable behavior and internal thought. For thousands of years, thought has been a sacred territory, the birthplace of creativity, the refuge of dissent, the sanctuary of identity.
Let's analyze this pattern.
Crossing that
Rerouting
line
the neural
may
pathways
unlock
now.
healing,
Confidence level is
communication,
high.
and understanding, but it may also redefine freedom itself. Because when thought is transparent, power sees deeper than ever before. Final reflection. The future is watching back. We are not powerless. The future of brain-AI integration is not predetermined. We decide what is allowed, what is protected, what is sacred. Technology does not erase ethics, it tests them. And perhaps the greatest breakthrough is not decoding the brain, but defining the boundaries around it. Because in the end, the most advanced civilization will not be the one that reads minds, it will be the one that respects them.
For millions of years, evolution shaped the human body. Stronger limbs, sharper vision, larger brains. But something changed. For the first time in history, evolution is no longer only biological. It is technological. We are not just building machines anymore. We are building extensions of ourselves. And the question is no longer, Will humans use AI? The question is, what happens when humans and AI begin to merge? Once, technology was a tool. The wheel, the printing press, the computer. Each amplified human ability. But AI is different. AI does not just amplify muscle, it amplifies cognition.
AI,
Imagine
optimize the
waking
layout
up
for maximum
and your
efficiency.
neural
Good.
interface
Now
has
simulate the
already
structural noise
summarized
detected.
the world's news, filtered for truth, relevance, and bias. Imagine learning a new language, not in years, but in weeks, because your AI partner adapts learning pathways directly to your neural patterns. Imagine creative collaboration where your thoughts flow seamlessly into digital sketches, music, architecture. Not typed, not spoken, thought. This is not replacement, this is partnership. In the coming decades, human intelligence may no longer be fixed. Memory could become searchable, focus could become adjustable, emotional regulation could become guided. Neural implants may help patients with memory loss restore clarity. Students could access adaptive cognitive tutors embedded within their own neural activity. Professionals could simulate complex scenarios instantly. But augmentation raises a profound
Seizure imminent.
shift.
Get the crash cart ready.
When intelligence
Prepare the
becomes
anti-seizure meds.
upgradable,
Cart is ready, doctor.
identity becomes fluid. Who are you when part of your thinking is assisted by an algorithm? Where does the human end and the system begin? Perhaps that boundary was never as rigid as we imagined. The future of symbiosis is not only enhancement, it is healing. Imagine depression detected at the neural pattern level before symptoms manifest. Imagine epilepsy predicted seconds before a seizure. Imagine paralysis reversed through thought-controlled prosthetics that feel natural. For millions living with neurological conditions, AI is not a philosophical debate, it is a lifeline. The merging of silicon and neurons may restore what injury or illness has taken away, and in doing so, it may redefine medicine entirely. Now, imagine something even bigger. What if individual minds could collaborate in real time? Not through keyboards, not through speech, but through shared cognitive networks. Scientists solving climate change by synchronizing insights. Global researchers modeling pandemics through direct neural simulation. Artists across continents co-creating immersive experiences directly from imagination. A collective intelligence, not replacing individuality, but enhancing collaboration. The internet connected our devices. Neural AI may one day connect our cognition, carefully, ethically, intentionally. But every expansion brings risk. If thinking becomes assisted, will we forget how to think alone? If memory becomes externalized, will we lose the beauty of forgetting? If AI filters our perception, will we experience a curated reality instead of an authentic one? The danger of symbiosis is not domination, it is dependency. True partnership requires balance. Technology must amplify human agency, not replace it. The future must be co-designed, not outsourced. For centuries, intelligence was measured in isolation. IQ scores, exams, individual performance. But symbiosis challenges that model. Perhaps intelligence will become relational. The ability to collaborate with AI effectively. The ability to question algorithmic output. The ability to remain deeply human in a world of increasing
Initiating
machine
global sync.
logic,
Metrics are populated.
empathy,
EU is lagging rerouting
creativity,
sources to optimize.
ethical
Agreed.
reasoning.
Syncing now.
These are not bugs in human cognition. They are features.
and they may become more valuable.
North
than
America
ever.
shows strong Q3 growth.
We
Asia is
often
accelerating.
ask,
Tokyo
will
leads.
AI
Europe is steady.
become
London is
more
stable. Connecting
human?
globally now.
But perhaps
North America
the
shows
real
strong
question
Q3
is,
growth.
Asia is
will
accelerating.
humans
Tokyo
become
leads.
more
Europe is steady. London is
augmented?
stable. Connecting globally
A
now.
generation may
Initiate
grow up
sequence.
with neural interfaces as normal
Steady now.
as smartphones. Children may never know a world without cognitive assistance. History may divide into two eras: before integration, after integration. Yet even in that transformed future, one truth remains. Consciousness is still experienced from within. Meaning still emerges from emotion. Purpose still arises from human desire. AI may enhance the canvas, but humanity still paints the picture. Final section, the choice ahead. The future of human-AI symbiosis is not inevitable. It is intentional. We can build systems
Energy levels
that
are
empower,
optimal. Initiate the neural
protect,
mapping sequence.
heal,
Confirmed. I'm seeing the
elevate.
pathways light up in real time.
Or we can build systems that exploit, control, replace, divide. Technology does not decide our destiny. We do. The most advanced civilization will not be the one with the most powerful AI. It will be the one that integrates intelligence without losing wisdom. Because in the end, the goal is not to become machines. The goal is to become more fully human with the help of machines. And perhaps the greatest evolution of all is not stronger bodies or faster processors, but a deeper understanding of what it truly means to think, to feel, and to coexist.
For thousands of years, being human meant something simple. You were your body, your memories, your struggles, your dreams. Your identity lived entirely within you. But now, for the first time in history, that boundary is beginning to blur. As artificial intelligence integrates with our tools, our work, and even our thoughts, we are forced to ask a question humanity has never faced before. What does it truly mean to be human? We already live partially outside ourselves. Our photos exist in clouds of data. Our conversations are stored on distant servers. Our preferences are mapped by invisible algorithms. But neural technology goes further. If memory can be enhanced, if thought can be decoded, if cognition can be assisted, then identity is no longer just biological. It becomes hybrid, part organic, part digital. And that changes everything. Memory shapes who we are. It connects our past to our present. It gives continuity to our story. But what happens when forgetting becomes optional? When experiences can be replayed perfectly? When knowledge can be instantly accessed? Does that make us stronger? Or does it change the way we grow? Because growth has always required imperfection. Forgetting softens pain. Time reshapes memory. Mistakes build wisdom. If identity becomes permanent and editable,
The words are
will
flowing
we
tonight.
still evolve the same
Transforming
way?
into stories.
And then there is intelligence itself. If an AI assists your thinking, helps you compose music, solve complex problems, regulate emotions, are those achievements still yours? Or are they shared? Perhaps the future will not measure identity by isolation. Perhaps identity will be defined by collaboration. Not human versus machine, but human with machine. Emotion remains our deepest signature. Joy, fear, love, loss. If technology can reduce suffering, stabilize anxiety, or heal trauma, some may fear we are losing something essential. But maybe identity was never about suffering. Maybe it has always been about awareness, the ability to experience, to reflect, to choose. That is something no algorithm replaces. And what about continuity? If your voice, personality, and cognitive patterns can be modeled, could a version of you live on digitally? Would that be you or a reflection?
Identity has always been shaped by mortality. Time gives urgency to meaning. It is our limits that make life precious. If technology stretches those limits, then the definition of life itself begins to shift. But here's the truth. No matter how advanced technology becomes, you will still wake up inside your own awareness. You will still feel hunger, curiosity, wonder. You will still make choices. Consciousness, the experience of being, remains deeply, undeniably human. AI may expand the mind. It may enhance memory. It may accelerate thought. But identity is more than cognition. It is intention. It is values. It is the quiet inner voice that decides who you want to be. The future of human identity is not something that happens to us. It is something we shape. We decide what remains sacred. We decide what becomes augmented. We decide where technology supports us and where it stops. The next evolution of humanity will not be defined by processors. It will be defined by wisdom, by whether we use intelligence to deepen empathy or replace it. We stand at a turning point
Look
in
at you,
history,
so full of
not
energy.
just technological,
I'm
but
so proud of
existential.
you.
The question is no longer, can we build it? The question is, who will we become because of it? And maybe the greatest achievement of this century will not be machines that think, but humans who think more clearly about what truly matters. If you found this exploration thought-provoking, if you care about the future of humanity, technology, and consciousness, subscribe to this channel, because the conversation about our future is just beginning, and the next chapter is already unfolding.